All right, welcome. Today we're jumping into a topic that can feel like a real roadblock in calculus too, trigonometric integrals. But I want you to think about them a little differently, not as a roadblock, but as a puzzle. And like any good puzzle, once you have the right strategies, let's call it a playbook, they become way more systematic and honestly, kind of satisfying to solve. So here's our game plan. We're going to start by really defining the problem. What makes these integrals tricky? Then we'll build our playbook, piece by piece. First up, the strategies for sine and cosine. Then we'll tackle tangent and secant. We've even got a cool trick for a special case, and we'll wrap it all up with a master checklist. So let's jump right in. Okay, so first things first, let's talk about the puzzle itself. You know that feeling, right? You see an integral with sine raised to the fifth power, or maybe cosine squared, and it just looks like a total mess. Well, our goal here is to turn that power struggle into a solved problem, giving you a clear, confident starting point every single time. Does this kind of thing look familiar? Staring at an integral that's just packed with powers of trig functions, it can be pretty intimidating. But here is the really good news. There is a clear, logical path for almost every single one of these. This isn't about guesswork, it's about having a game plan. Okay, let's start building our playbook, and we'll begin with the most common pair out there, sine and cosine. This is really the foundation for everything else. And the core idea? It all comes down to a simple question. Are the powers odd or even?
And there's a really cool pattern here. If either the sine or the cosine power is odd, that's your green light. You just peel off one factor of that function. That one little piece is going to become your du in a u substitution. Then you use that classic Pythagorean identity, sine squared x plus cos squared x equals 1, to change everything else into the other trig function. It is such a clean and powerful move.
But what happens if both powers are even? Well, our save one strategy completely falls apart. There's nothing to save. So we have to switch plays entirely. And for this, we bring in the heavy hitters, the half-angle identities. Their whole job is to reduce those powers and turn the problem into something way more manageable. Okay, let's actually put this into practice. We've got the integral of sine cubed. The power, 3, is odd. Perfect. That's our trigger. We save one sine x, which we'll use for our du later. We then convert the sine squared x that's left into 1 minus cosine squared x. See what happened? The stage is now perfectly set for a simple u substitution where u equals cos of x. The rest is just basic integration and plugging cos x back in at the end. Okay, quick heads up here. This is a super common mistake, so listen up. When you let u equal cos x, what's its derivative? Well, du is negative sine x dx. It is so easy to forget that little minus sign, and if you do, it'll throw off your entire final answer. So please always double check your du when your u is cosine. Let's run another play. This time, the cosine power is the odd one, so we save one cosine of x. We convert the leftover cos squared x to 1 minus sine squared of x. Now look at what's left. Besides our saved cosine, everything is in terms of sine. That is the signal for our substitution, u equals sine of x. From there, it just becomes a simple polynomial integral. Easy peasy. All right, you've totally got the sine and cosine game down. So what's next? Let's see how this same kind of logic applies to our next dynamic duo, tangent and secant. The specific tactics are a little different, but the core strategy of setting up a perfect u substitution, it's exactly the same. For this pair, our triggers are different. The very first thing you're going to look for is an even power on secant. If you've got it, you save a secant squared x. Why? Because that's the derivative of tan x. If you don't have that, then you look for an odd power on tangent. If that's the case, you save a secant x tan x pair. Why? Because that's the derivative of secant x. It's all about saving the exact derivative that you need for your substitution. Let's walk through one. The secant power is 4. It's even. That's our trigger. We immediately pull out a secant squared x and just set it aside. That's our future du. We then convert the other secant squared x into 1 plus tan squared x. Now, the whole integral, except for our du, is in terms of tangent. The substitution u equals tangent of x becomes totally obvious, and from there, the whole problem just falls apart.
All right, but what about those weird ones? What happens when our power-based strategies just don't apply at all? This usually pops up when you're integrating a product, something like sine 4x times cos 3x, where the angles inside, the arguments, are different. For this, we need a totally different play from our book.
And that play is using the product to sum identities. Think of these formulas as your secret weapon. Yeah, they look a little complicated, but what they do is basically magic. They transform a really difficult multiplication problem into a simple addition or subtraction problem. And let's be honest, integrating a sum is always, always easier than integrating a product.
So check this out. We spot the form sine A cos B, and we apply that identity directly. And just like that, our messy product becomes a simple sum of sine x and sine 7x. And those are two integrals you could probably do in your sleep. This technique turns what looks like a dead end into a totally straightforward path to the solution. Okay, we have covered a ton of ground. We've got all the main plays down. So now let's bring it all together into one unified strategy, a master checklist you can use every single time you see one of these trig integrals. So here it is. This is your game plan, your decision tree. Think of it like a flowchart. You see a problem, you just start at the top and work your way down. Is it sine and cosine? Okay, check for odd powers first, then even. Is it tangent and secant? Check for an even secant power, then an odd tangent power. Are the arguments different? Don't even hesitate. Go straight to product to sum. Following these steps takes all the guesswork out of it and gives you a confident plan of attack. And that really brings us to the single most important takeaway from all of this. Yes, there are formulas, you have to know them. But success with these integrals isn't about just brute force memorization. It's about pattern recognition. It's about looking at an integral, identifying its key features, and confidently choosing the right strategy from your playbook. So, the playbook is officially in your hands. You've got the strategies for odd powers, for even powers, and for those tricky cases with different arguments. The only question left is, what problem are you going to go solve with it first?